see we're going from magnetic up to analytical and back down to a thermal problem. That's the loop we're illustrating. I try and find that Steinmetz function. There it is. And I'll try to highlight the core piece of, there it is. I'm highlighting the actual Steinmetz function now, which is, it's a constant times the frequency times the flux density to an exponent, and the exponent happens to be 1.9. You can see I'll highlight now the two parameters for that function. There they are there, and I obtained those from the Snelling book, where he stated that he experimentally determined those to be representative of the core loss for the power ferrites that I was using. So I had a lot of functions here that I wrote for this webinar. The whole thing took me maybe 1 to 2 days to write and debug and get working. This is the hyperbolic tangent function, which generates the BH curve as Boseloff suggested. There's a lot of other functions here, mainly to do with housekeeping. I won't go into those in too much detail. There's about 6 or 8 functions that I used. I hope I wasn't too brief or too detailed in just explaining how the code, or my code works. Now I'll turn to the results, and they're in 2 sections. The results, of course, are saved in that chain of problems. As I showed, the results are there for all time. Once the problem's solved, the QuickField problems all remain on the computer's hard drive, and they can be resurrected at any time. You can change things and run them again, or you can use them to see what you did as an archive of how you designed the particular job. What I also like to do, and I'll turn to Excel spreadsheet now. As I said, I like to output results in graphical form, and I can go through some of the outputs. Here is one of the BH curves. I drew it as I wrote it into QuickField. I drew it on a graph on Excel, just so I could see what was going on. Greatly helps to debug a program if you're generating graphs of what you're doing on the run. And this graph, I hope it's not too obscure, but to save solving time, and I'll go back to this BH curve, I only solved a quarter cycle on the basis, my rationale was that I'm using the original trajectory plus a Steinmetz function. So if I solve in that direction, a quarter cycle in that direction, the Steinmetz losses are going to be exactly the same as if I solve in a quarter cycle back that direction, and also exactly the same as if I solve out in the negative direction and back into there. So I only need to do a quarter of what you might think you need to do in a full cycle. And the only caveat is, if you had a DC bias, you could not do that. You would have to solve with the DC bias and with the full cycle. So anybody designing, for example, a choke that's a DC smoothing choke would have to use a little bit more elaborate solving method than what I'm illustrating today. So I only solved a quarter cycle, and the results in the spreadsheet show that.